All right, guys. Let's go ahead and start Trig Identities. We're pretty much going to wrap things up right here. We had a good talk when we talked about Notes 11. Let's continue that momentum. So in Notes 11, we talked about cosine squared plus sine squared equals 1. And you can always rewrite these cosine squared plus sine squared equals 1. You can always rewrite this expression. We call this the Valentine's equation, right? I mean, it's really just a Pythagorean trig identity. If you move the sine squared to the right, then you get cosine squared equals 1 minus sine squared. If you move the cosine squared to the right and leave the sine squared alone, then you get this expression. There's nothing to write. I already wrote everything for you, so you're good. You don't have to necessarily write anything in there unless you want to highlight or something. Maybe on this one, maybe we can write a little bit. That 1 plus tan squared equals secant squared, guys, that's derived from somewhere. Where is it derived from? They all come from the Valentine's formula. Cosine squared plus sine squared equals 1. And if you divide everything by cosine squared, divide by cosine squared, divide by cosine squared, divide by cosine squared, you get 1 plus tan squared equals secant squared. See? And there it is. And then, of course, there's different ways that you can reformat it. Oh, something that I got to talk about that you guys have been doing that it's a no-no. Guys, don't leave cosine or sine alone. They need an argument. They need to have a theta or an x or something. It's like saying f of x. You don't ever see f equals, I mean, maybe sometimes you do, but you don't see f equals 3x plus 2. You see f of x equals 3x plus 2. So it's cosine of theta or sine of theta. Sometimes I don't put parentheses. I get that a bad habit from textbooks. Textbooks don't like to put parentheses or for whatever reason. But you should be putting parentheses, cosine of theta, cosine of x, sine of x. Cool or not cool? This is not multiplication. Some of you are saying, like, how do I get rid of sine here to get, like, how do I get rid of this sine here to get x by itself? To get rid of it, you got to do the inverse sine. X equals arc sine of y. So it's not sine times x, guys. It's sine of x. It's a function. Cool or not cool? Okay. So I think we're good with that. Oh, another side note. If you write this, you're not telling me that sine is squared. You're telling me that x is squared. Maybe if you put the x like that in parentheses, maybe I think you're trying to tell me sine squared. But it's good habit to do this. If you're trying to say that sine is squared, you use it like this, sine squared of x. Chop, how do I use that sine squared of x? Okay, let's say I had this, sine squared of pi over 6. Because some of you guys don't know how to use it. So if I have sine squared of pi over 6, what is sine of pi over 6? Uh-oh. What's sine of pi over 6? 1/2. So here's how you use it. If there's a square there, you put a square right there. That's what it means. Sine squared of pi over 6. It means 1/2 squared. What's 1/2 squared? 1/4. That's just a side note for you guys, because that's what we're having issues with. Are we okay now? Okay. All right. Going back, cotangent squared plus 1 equals cosecant squared. Again, where does this come from, guys? Well, it comes from the cosine squared x plus sine squared x equals 1. And if you divide everything by sine squared, divide by sine squared, divide by sine squared, divide by sine squared, then you get cotangent squared x plus 1 equals cosecant squared x. Cool or not cool? Cool. All right, guys. Which is an even function? Which is an odd function? Why does that matter? Maybe I should have put what is an even function instead of which. I am referring to sine and cosine. That's what we're referring to. What is an even function? An even function reflects across the y-axis. So a very famous even function is something like, well, I guess let me give you the property first. An even function has this property. So what's a good even function? Something like x squared plus 1. So let's see if this property is true. This just means reflects across the y-axis. So if I type in the negative x, let's see if I get f of x. Negative x plus its squared plus 1. What's negative times a negative? X squared plus 1. OMG, look at that. F of negative x does in fact equal f of x. That's what you call an even function. So which ones are even for between sine and cosine? the cosine function. Cosine of negative x will equal cosine of x. Chav, why is cosine even? Well, because cosine looks like this, guys. Look, it's symmetric on the y-axis. I tried to make it symmetric. It's symmetric on the y-axis. I just suck at drawing. Are you guys okay so far, guys? Okay, if cosine is symmetric, that means its reciprocal is symmetric. What's the reciprocal of cosine? Secant. So secant of negative x does in fact equal secant of x. All right, I'm going to change my colors to blue. What is an odd function? An odd function is symmetric about the origin. And it follows this property. F of negative x equals negative f of x. It must go through the origin. Now later on when we start doing end behavior, you're going to see some functions have an odd tendency, but it must go through the origin, guys. So here you go. So let's see. What's an odd function that we all know about just for kicks? F of x equals x cubed. So check it out. If I type a negative x, I'm going to have negative x to the third power. And negative times a negative times a negative is a negative. So I have negative x cubed. And look, that definitely is negative of f of x. So it does follow this property. So what is an odd function? Sine. Sine of negative x is going to equal negative sine x. If sine is odd, then its reciprocal is odd. Cosecant of negative x equals negative cosecant of x. And tan is also an odd function. Tan of negative x equals negative tan of x. And if tan is an odd, so is its reciprocal, cotangent. So I think we covered everything. Cosine, sine, tan, and secant, cosecant, cotangent. Yep, we got them all. We got them all, like Pokemon. How are we feeling, guys? All right? All right. What about when sine, cosine, tangent are squared? Guys, when they're squared, come on, Chavez, focus, miss. When they're squared, it does not matter because negative times a negative is a positive. So look, guys, if I have an angle here, so let's choose an angle. Power 4 and negative power 4. And I'm going to say sine. Sine of negative power 4. Well, here it is, negative power 4. I already said power 4. That is square root of 2 over 2, comma, negative square root of 2 over 2. And then that power 4, that's square root of 2 over 2, comma, square root of 2 over 2. And I'm talking about when it's squared. So sine of negative power 4 is negative square root of 2 over 2. And then sine of power 4 is square root of 2 over 2. And I know what you're saying, Chav. You said it doesn't matter whether I have a negative argument. I haven't squared it. I'm waiting for you guys to catch up. If I square them, yeah, I'll wait. If I square them, guys, look, sine squared. So if I square that, that means I square this. If I square this, I square this. Look what happens. Negative times a negative is a positive. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. So look, I get a half. Square root of 2 times square root of 2 is 2. And 2 times 2 is 4. And look, I get another half. So it does not matter. All of them, so all of them. So sine squared of negative theta is equal to sine squared of theta. And it's true for all. For cosine, it wouldn't have mattered because it's an even function anyways. But cosine negative theta is equal to cosine squared of theta. And tan squared of negative theta is equal to tan squared of theta. And it's like that for all of them, including secant, including cosecant, and including cotangent. All. So you know what? I'll just put them all here. I said secant and cosecant. All of them. If you have a negative argument and you're squaring them, the argument's gonna turn to a positive. It's the same. It's the same. It's equivalent. Hopefully, we showed that with this right here. Sine of negative pi over 4 squared, sine of pi over 4 squared. Or sine squared of pi over 4 and sine squared of negative pi over 4. Because negative times the negative is a positive. Are we okay so far, guys? I know you want to get into the action. And I still haven't done the polling with you guys. I need to do that soon. The poll, have we done a poll with you guys? We have? Okay, yeah, but we haven't done it consistently. That's on me. What identities should I know cold? Guys, cold before you graduate, before you get out of pre-cal, you should know this cold. What is tan? What over what? Sine over, yeah, you can say y over x. Sine over cosine. You should know that cold. Cotangent. Cosine over sine. And then the Valentine's formula, what is it? Okay, we'll start with cosine. Cosine squared plus, there it is. Cool or not cool? Maybe something that I would add here, guys, we should also know that 1 minus cosine squared is the difference of squares. See, 1 times 1 cosine theta times cosine theta. That's the difference of squares. A squared minus b squared equals a plus b times a minus b. So we should know that that is the same thing as 1 plus cosine theta times 1 minus cosine theta. And it's true for all of them. 1 minus sine squared is 1 plus sine theta. 1 minus sine theta. And then heck, just for kicks, cosine squared theta minus sine squared theta. That's the difference of squares. Cosine theta plus sine theta times cosine theta minus sine theta. Now it does say what identities. This is not necessarily an identity. This is just algebra. But it'd be nice if you knew that. Cool or not cool? Okay, so this that I'm circling are not necessarily identities. It's just algebra. I'm going to put algebra. Algebra. Okay, I'll stop. I'm just playing. I'm just kidding. Meow meow. You know, get it? Because a kitten. Meow. Okay. Tough crowd. Okay. Cosine and sine differ by a phase shift of pi over 2. What does that mean? All right, guys, focus. This is cosine. I didn't draw it perfect, but that's fine. And let me see. The one in red is cosine. I'll say y equals cosine x. And the one in blue is y equals sine x. The difference between this peak and this peak is pi over 2. The difference between those two values, guys, here's 0. This is pi over 2. Sine of pi over 2 is 1. The difference between those two values is pi over 2. So because of that, because the difference is pi over 2, we have a unique situation. We have this cosine. I guess I'm going to say x instead of theta. Cosine x is similar to sine of pi over 2 minus x. And sine x is equal to cosine of pi over 2 minus x. Chav, why did you write it like that? Usually you say theta minus pi over 2 or x minus pi over 2 to shift. I wrote it that way. That way they can both look similar, quote unquote. See? Now check it out. I'm going to take my calculator and I'm going to go to y equals. And I'm just doing this just to show you guys. Look, cosine x, and I'm going to write sine alpha y equals enter. I'm going to put the pi over 2 there. Pi over 2. Close it. Don't worry, I'm going to go back. Minus x. Check it out, guys. Window 0 to 2 pi. Now it's going to go fast. X scale, pi over 2. Y min negative 1.3. 1.3. Y scale by 1. Okay, that's fine. Check it out. It's going to go fast, guys, because I got a computer here. Look at this. Boom, boom. Do you see how the blue and red are the same graph? So that means they're both the same. Check it out. If I turn off Y1 and Y2, Chop, how do you turn it off? You go to the equal sign, you just push enter. And I go to Y3, I'm going to put sine X. And I'm going to go to Y4, I'm going to push cosine X, alpha, Y equals enter. I'm going to put a pi up there, pi over 2. And then move, and then minus X. Close. Check it out, guys. Check it out. Ready? It's going to go fast. Bam. The black, pink. Same graph. Cool, right? You could have also looked at the table. Check it out. Look at the table, how everything's the same for Y3 and Y4. So hopefully that convinces you guys, because they just shift, but they're only pi over 2 apart. So that's why we have this property here. So I think we're good. I think we're doing so good. All right, here we go. Practice problems. Yes. Let's get back at it, Professor. All right, here we go, guys. What type of questions will I see in my future exam? Well, I guess you still have a day today for your UH trig identities, so you'll see this one. Remember what we said about sine? Sine was what? Positive or negative? I mean, odd or even? Odd. So sine of negative theta is the same thing as negative sine theta. And then cosine's an even function. So cosine of negative theta is the same thing as cosine theta. So I got negative divided by positive. So it's going to be a negative. And then sine over cosine is just what? Tan. So there it is. I look for negative tan. And that's my answer. Are we okay with that? Okay. Let's go to the next one, guys. Yeah, on the outside, see? Sine of negative theta is equal to negative sine theta. That's what I did. See? There's my negative. No, I know. But you do that every time. Yeah, because that's the odd property. That's part of the odd property, see? F of negative x equals negative f of x. All right, continuing. Which of the following is equivalent to this? So you see it and you're probably like, I don't know what to do. I don't know what's my first move. All right, guys, the first move, come on, Chop, let's focus. The first move is that cosine squared. We know that cosine squared plus sine squared equals 1. So, look, all you got to do is move that sine squared to the right. Cosine squared theta equals 1 minus sine squared. As soon as you get that, so you're going to put that in terms of cosine squared. So I'm going to write 1 minus sine squared over 1 plus sine theta. And no, do not cancel anything out. You guys like to cancel stuff out. You can't cancel unless you have inverse operations. Multiplication and division are inverse operations. Okay, what I'm trying to say is this. You guys do this all the time. You cancel out the b's. You cannot cancel out the b's, guys. You can only cancel when there's a multiplication and division. A times b over b times c, yes, those you can cancel out. But you can't cancel these out, no, because you can't factor out a b. Adding and dividing are not inverse operations. So don't do that. All right, what do I do next then? Child, I don't know what to do. Well, 1 minus sine squared is the difference of squares. So I can rewrite the 1 minus sine squared as 1 plus sine theta times 1 minus sine theta. Hopefully you remember that from your algebra days. And now, look, check it out. Yes, now you can cancel because look, these are multiplying by each other, guys. That's a product. 1 plus sine times 1 minus sine, that's a product. Divided by 1 plus sine. So now you can take those two dudes out. Not take them out like take them to a restaurant. Like take them out like just delete. Cool or not cool? So all you have left is 1 minus sine theta. And then I look for that. Did that make sense, guys? Okay, let's go to the next one. Guys, don't get confused. Please make sure you know that x plus 2 pi just means that you're in the same location. If you have a unit circle and you're right here and you go 1 revolution, that is 2 pi. You just went 1 revolution. Am I still in the same location? Yes. So anytime you see cosine x plus 2 pi, really all of them, that you're just going to be, it's the same thing as cosine x. Same thing for sine. Same thing for tan. Just make a note that tangent has a period of pi. So every time you go plus pi, you're in the same, like it's the same value. So there it is. So I'm going to rewrite this. It's going to be cosine x over sine x plus sine x over cosine x. Once you get it to here, it goes back to when you were in elementary. How do you add two fractions? Common denominator. So I'm going to multiply the right dude by sine x over sine x. I'll multiply the left dude by cosine x over cosine x. Now, some of you have a habit of just writing times cosine x. Don't do that, guys. It needs to balance out. You need to be multiplying by 1. Cosine x over cosine x is 1. So now look what you have. Cosine times cosine, cosine squared x. Cosine x times sine x, cosine x sine x. Plus sine x times sine x, sine squared x over cosine x sine x. Add them up. So you have cosine squared x plus sine squared x all over cosine x sine x. Hopefully something is happening that is telling you what? We've done this enough. We've done this enough times. We should be... Yeah, that's the same thing as 1. That's the same thing as 1. Guys, if this is not getting easier for you guys, come into tutoring. I haven't been seeing you guys. 1 over cosine x sine x. Yeah, we've been doing this for a week. So if it's not getting easier, come in. Expand. Look, Chubb, I don't have that answer. Where's that answer? It's not in there. Guys, expand it. Look. 1 over cosine x times 1 over sine x. Notice that 1 over cosine is just secant x, and 1 over sine is cosecant x. Isn't that what I wanted? Or I guess that's what we have. We're looking for that answer choice, right? So equals secant x, cosecant x. There it is. Cool or not cool? Let's keep going. Let's keep going. All right. Later on, once we have more experience, I will talk about the different hacks. Right now, this is y'all's first rodeo, maybe your second rodeo, maybe your third rodeo, because we're getting better. So you guys will probably say that the best way to subtract these is to find a common denominator. So let's do that. I'm going to multiply this one on the right by, let's see, 1 minus sine theta over 1 minus sine theta. And I'll multiply this one on the left by cosine cubed theta over cosine cubed theta. I think I would have probably done something with that cosine cubed, but that's fine. We'll leave it right there. I think I probably would have done it like cosine squared times cosine and then replace the cosine squared, but we're not there yet, so we'll just leave it like this. When we multiply it, here's what we're going to get. You're going to get cosine cubed theta times secant theta over cosine cubed theta, parenthesis 1 minus sine theta, minus in the top 1 plus sine times 1 minus sine. Do you agree that's the difference of squares? So I'm going to write it like this. 1 minus sine squared theta over cosine cubed theta times 1 minus sine theta. Okay, I'm ready. Distribute. I was going to replace that 1 minus sine squared, but I'm going to leave. I decided to leave it because I can see something happening anyways. You'll get to the same answer anyways, regardless. So it just depends on how much, how advanced you are with how many, it really depends how much practice you've done, like how many problems you've done. All I'm doing is distributing, guys. That's all I'm doing. The same denominator, cosine cubed theta, 1 minus sine theta. So catch up to here. This that I'm circling, secant is the reciprocal of cosine. So you can rewrite this as cosine cubed theta times 1 over cosine theta. And when I do that, one of the cosines cancels. Do we see that, guys? So here's what you get. And I'm going to rewrite it so you guys can see. I'm going to have cosine squared theta, and I'm going to write the sine squared first, plus sine squared theta minus 1 over cosine cubed theta, parenthesis 1 minus sine theta. What is cosine squared plus sine squared? 1. It's uno, 1. So look, guys, you're done. 1 minus 1 over cosine cubed theta, parenthesis 1 minus sine theta. What's 1 minus 1? Yeah, say it. And 0 divided by anything is 0. Yes. Oh, I just moved it. There's no equal sign. See here's sine squared. I just switched the sine squared and the 1, and since there's no equal sign, the sign stays the same. All right, guys. All you have now is just one little activity, and you should be able to finish it because the other classes finished it. It's only 6 questions. 2 of them are multiple choice, and that's it. You can work together. And I want it. You got an hour, guys. An hour for 6 questions. That's nothing. An hour for 6 questions. You'll finish it. You can work together. That's finish.